Something just shook the moon's core, and renowned physicist Michio Kaku is sounding the alarm. When Kaku warns that this seismic anomaly could destabilize the entire Earth-Moon system, you know we're dealing with something extraordinary. Here's the mind-blowing truth. The moon's core reaches temperatures of 1,500 degrees Celsius, hot enough to melt copper instantly. Yet scientists believed it was completely dead for billions of years. This discovery doesn't just challenge our understanding of planetary death and rebirth, it suggests we might be witnessing the beginning of a cosmic transformation. But did you know the moon has been ringing like a bell for over 50 years? The mysterious seismic signal. Something just shook the moon, and it wasn't supposed to happen. Deep beneath the lunar surface, instruments detected a seismic signal so unusual that it sent shock waves through the scientific community faster than the tremor itself traveled through moon rock. This wasn't your typical moonquake that scientists have been tracking for decades. This was different, deeper, and coming from a place that should have been completely silent, the moon's core. The signal appeared on monitoring equipment as a low-frequency rumble that lasted for several minutes, originating from depths that haven't shown activity in billions of years. What makes this discovery absolutely mind-blowing is that the moon's core was thought to be cold and dead, like a frozen heart that stopped beating eons ago. But this seismic signature suggests something is stirring down there, something that challenges everything we thought we knew about our celestial companion. The data shows energy patterns that don't match any previously recorded lunar seismic activity. Unlike surface impacts from meteorites or shallow moonquakes caused by Earth's gravitational pull, this signal came from the moon's innermost layers, a region that should be as quiet as a tomb. Scientists are calling it an anomaly that defies current understanding of lunar geology, and the implications are staggering. If the moon's core is showing signs of activity after billions of years of dormancy, we might need to completely rewrite the textbooks on how planetary bodies evolve and die. Michio Kaku's warning. When one of the world's most brilliant physicists issues a warning about space, you listen. Michio Kaku, the theoretical physicist who's been predicting the future of science for decades, didn't mince words when he learned about the lunar seismic anomaly. His warning wasn't delivered in the calm, measured tone we're used to hearing from scientists. This was urgent, almost alarmed. Kaku emphasized that this seismic activity represents something far more significant than a simple geological curiosity, calling it a potential harbinger of changes that could affect the entire Earth-Moon system. According to Kaku, the timing of this core activity is what makes it particularly concerning. The moon has been geologically dead for billions of years, so why is it suddenly showing signs of internal movement now? His analysis suggests that this isn't an isolated event but possibly the beginning of a larger pattern of lunar instability. Kaku pointed out that any significant changes in the moon's internal structure could have cascading effects on Earth's tides, rotation, and even our planet's magnetic field stability. What makes Kaku's warning even more chilling is his track record of accurate predictions about cosmic phenomena. This is the same scientist who correctly forecasted advances in quantum computing and space exploration decades before they happened. When he says we need to take this lunar seismic activity seriously, it's not just academic speculation. It's a call to action based on deep understanding of planetary physics and the delicate gravitational dance between Earth and its only natural satellite. What we know about the moon's core. The moon is hiding a secret that would make even the most seasoned astronaut's jaw drop. Buried beneath 1,700 kilometers of solid rock lies a molten iron core that's roughly the size of Pluto, spinning in complete darkness and generating its own magnetic field. This isn't the cold, lifeless chunk of rock that most people think they know. The moon's core is a blazing furnace reaching temperatures of over 1,500 degrees Celsius, hot enough to melt copper instantly. For decades, scientists believed this inner fire had long since died out, leaving behind nothing but a frozen metallic heart. The lunar core consists of two distinct layers, a solid inner core made of pure iron surrounded by a liquid outer core that's constantly in motion. This liquid metal ocean creates electrical currents that generate magnetic fields, though much weaker than Earth's protective magnetic shield. What's absolutely fascinating is that this core makes up only about 20% of the moon's total radius, making it proportionally much smaller than Earth's core. Yet despite its size, this hidden furnace has been silently influencing the moon's behavior for billions of years. Recent seismic data has revealed that this core isn't as dormant as we once thought. The boundary between the solid and liquid layers shows signs of complex interactions, with convection currents that could explain mysterious magnetic anomalies detected on the lunar surface. Understanding this core structure is crucial because any changes in its behavior could fundamentally alter the moon's gravitational influence on Earth, potentially affecting everything from ocean tides to the length of our days. Previous lunar seismic activity. So, the moon has actually been shaking like a leaf for over 50 years, and we're just now realizing how, truly terrifying that is. Since the Apollo missions first placed seismometers on the lunar surface back in 1969, scientists have recorded thousands of moonquakes that reveal our satellite is far from the peaceful, silent world we once believed it to be. These aren't gentle tremors either. Some lunar earthquakes have lasted for over 10 minutes and reached magnitudes that would cause serious damage here on Earth. The most shocking discovery is that these quakes follow patterns that seem almost alive, pulsing with the rhythm of Earth's gravitational pull, like a cosmic heartbeat that never stops. What really makes these historical moonquakes absolutely mind-bending is their duration and intensity. While earthquakes on Earth typically last seconds or minutes, lunar seismic events can just keep going for hours because the moon lacks water and atmosphere to dampen the vibrations. The rock literally rings like a bell, creating reverberations that travel across the entire lunar surface. Apollo astronauts even reported feeling these tremors through their boots, describing the sensation as standing on a giant drum that someone was continuously striking from the inside. Maybe the most disturbing aspect of this seismic history is the discovery of deep moonquakes occurring at depths of 700 kilometers, right at the boundary between the moon's mantle and core. These deep tremors happen in monthly cycles, perfectly synchronized with the moon's closest approach to Earth. Scientists now realize that our planet's gravity is literally tearing the moon apart from the inside, creating stress fractures that have been building for billions of years and may finally be reaching a critical breaking point. The implications of this discovery. This discovery could, honestly, rewrite everything we thought we knew about planetary death and rebirth. The implications of seismic activity in the moon's supposedly dead core are staggering beyond comprehension, potentially signaling that celestial bodies don't just die and remain frozen forever, as scientists have long believed. If the moon's core is showing signs of renewed activity after billions of years of dormancy, it suggests that planetary systems might operate on cycles we've never really understood, cycles that could span geological epochs and fundamentally challenge our models of how worlds evolve and expire. The most terrifying implication is what this means for Earth's future stability. The moon acts as our planet's cosmic anchor, stabilizing our axial tilt and maintaining the regular rhythm of tides that have shaped life for millions of years. Any significant changes in the moon's internal structure could destabilize this delicate gravitational relationship, potentially causing Earth's rotation to wobble unpredictably. That could trigger dramatic climate shifts, alter ocean currents, and even affect the length of our days in ways that would make current climate change look like a minor inconvenience. Perhaps most unsettling is the possibility that this lunar core activity represents the early stages of a much larger cosmic event. Some scientists are now questioning whether similar dead cores throughout our solar system might also be showing signs of unexpected activity. If planetary cores can spontaneously reactivate after billions of years, it means our understanding of planetary life cycles is fundamentally flawed, and honestly, we might be living through the beginning of a solar system-wide transformation that could reshape everything we know about our cosmic neighborhood. How scientists detected this signal. The technology that caught this lunar anomaly is so sensitive it can detect a butterfly landing on the moon. Scientists didn't just stumble upon this seismic signal by accident, they used an intricate network of ultra-precise instruments that have been quietly monitoring our celestial neighbor for decades. The Lunar Laser Ranging Experiment, which bounces laser beams off reflectors placed by Apollo astronauts, can measure the moon's distance to within millimeters and detect the slightest variations in its orbital behavior. Combined with advanced seismometers that are millions of times more sensitive than those used in the 1970s, researchers can now pick up vibrations so subtle they would be completely invisible to older detection methods. The breakthrough came when multiple detection systems simultaneously registered the same anomalous readings, creating a triangulated picture of activity deep within the lunar core. Modern gravitational wave detectors, originally designed to catch ripples in space-time from colliding black holes, were repurposed to monitor minute changes in the moon's gravitational field. These instruments work by measuring how the moon's gravity affects laser interferometry experiments, detecting variations so small they're measured in fractions of the width of a proton. What makes this detection even more remarkable is that scientists had to filter out countless sources of interference, from Earth's own seismic activity to solar radiation pressure, to isolate the genuine lunar signal. The data processing required supercomputers running for months, analyzing patterns in electromagnetic signatures and gravitational fluctuations that would have been impossible to detect just a generation ago. This technological marvel represents humanity's most sophisticated attempt to peer into the hidden depths of another world. The moon's hidden secrets. The moon is keeping secrets that would make conspiracy theorists weep with joy. Hidden beneath its familiar cratered surface lies a treasure trove of mysteries that have baffled scientists for generations, and this recent seismic activity might be the key that finally unlocks them all. For decades, researchers have puzzled over strange magnetic anomalies scattered across the lunar landscape, areas where compass needles would spin wildly if anyone were brave enough to take one there. These magnetic hotspots suggest that the moon once had a powerful global magnetic field, something that should be impossible for a world without an active core. Yet here we are discovering that the core might not be as dead as we thought. Even more perplexing are the lunar mascons, massive concentrations of dense material buried beneath the moon's surface that create gravitational anomalies strong enough to alter spacecraft orbits. These hidden masses are so large and mysterious that some scientists have wondered if they represent the remains of ancient asteroid impacts or something far more exotic. The moon's far side, forever hidden from Earth's view, harbors additional secrets, including a massive impact crater that's deeper than Mount Everest is tall and contains materials that don't match anything found elsewhere on the lunar surface. Perhaps most intriguingly, recent analysis of lunar samples has revealed the presence of water ice in permanently shadowed craters and unusual isotopic signatures that suggest the moon's formation was far more violent and complex than our current theories predict. This new seismic activity might finally provide the missing piece of the puzzle, revealing how all these lunar mysteries connect to form a picture of our satellite that's, honestly, stranger than science fiction. What this means for Earth. Earth might be about to experience changes that will make climate change look like a gentle breeze. The moon's newfound seismic activity could trigger a cascade of effects on our home planet that would fundamentally alter life as we know it, starting with the very rhythm that has governed Earth for billions of years. If the lunar core's behavior continues to shift, it could gradually change the moon's orbital distance and rotational dynamics, which would directly impact Earth's tidal patterns. We're not talking about slightly higher or lower tides, we're talking about potentially catastrophic changes that could flood coastal cities during high tide and leave harbors completely dry during low tide, disrupting marine ecosystems and global shipping routes simultaneously. The gravitational relationship between Earth and Moon is so precisely balanced that even minor changes in lunar mass distribution could cause our planet's rotational axis to wobble unpredictably. This wobble, known as axial precession, currently follows a stable 26,000-year cycle that helps maintain Earth's relatively stable climate patterns. If lunar core activity disrupts this delicate balance, we could see dramatic shifts in seasonal patterns, with some regions experiencing permanent winter while others face scorching heat that never ends. Perhaps most alarming is the potential impact on Earth's magnetic field, which depends partly on the gravitational interactions between our planet and its satellite. Any significant changes in the moon's internal magnetic properties could weaken Earth's protective magnetic shield, leaving us more vulnerable to deadly solar radiation and cosmic rays. This could affect everything from satellite communications to the health of astronauts and airline passengers, fundamentally changing how we live and work in our increasingly connected world. Future lunar missions. Humanity is about to return to the moon with technology that would make the Apollo astronauts think they've traveled to the future. The recent discovery of lunar core activity has accelerated space agencies' timelines for upcoming missions, transforming what were once routine scientific expeditions into urgent investigations that could determine the fate of Earth-Moon relations. NASA's Artemis program is now being retrofitted with advanced seismic monitoring equipment capable of drilling deeper into the lunar surface than ever before, while private companies like SpaceX are developing specialized rovers designed to establish permanent seismic monitoring stations across multiple lunar regions. These aren't your grandfather's moon missions. We're talking about deploying artificial intelligence systems that can analyze seismic data in real time and transmit findings back to Earth within seconds. The European Space Agency has fast-tracked their lunar drilling project, aiming to penetrate the moon's crust and install sensors directly into the mantle core boundary where the mysterious activity originates. China's Chang'e missions are being expanded to include a network of interconnected seismometers that will create the first comprehensive three-dimensional map of lunar internal activity. Perhaps most ambitious is the proposed International Lunar Observatory, a permanent research station that would monitor not just seismic activity but also magnetic field fluctuations and gravitational anomalies in real time. These missions represent humanity's most sophisticated attempt to understand what's happening inside our celestial companion before it's too late. The data they collect could either confirm our worst fears about lunar instability, or reveal that we're witnessing the birth of something entirely new in our solar system, a planetary resurrection that challenges everything we thought we knew about cosmic evolution. The bigger picture. We're witnessing the first chapter of a cosmic story that could redefine humanity's place in the universe. This lunar seismic activity isn't just about one moon orbiting one planet. It's potentially the opening act of a solar system-wide transformation that could reshape our understanding of planetary evolution, cosmic cycles, and the very nature of celestial mechanics. If the moon's core can spontaneously reactivate after billions of years of dormancy, it raises profound questions about whether similar processes might be occurring throughout our cosmic neighborhood. Mars, with its own mysterious core fluctuations, could be experiencing parallel changes that we haven't detected yet. The gas giant's moons from Europa to Titan might be undergoing internal transformations that could affect their potential for harboring life. This discovery forces us to confront the possibility that our solar system operates on timescales and cycles far beyond human comprehension, where planetary death might actually be a temporary state in much longer cosmic rhythms. The implications extend beyond our immediate celestial environment. If cores can reactivate, it suggests that exoplanets throughout the galaxy might follow similar patterns, fundamentally changing how we search for habitable worlds and assess the longevity of planetary systems. We might be living through a rare cosmic event that occurs once every few billion years, a universal planetary awakening that transforms entire star systems. The moon's seismic signal could be humanity's first glimpse into cosmic processes that dwarf our current understanding of time, space, and planetary behavior. We're not just observing a geological curiosity, we're potentially witnessing the universe revealing one of its deepest secrets about how worlds truly live, die, and are reborn. So there you have it. Michio Kaku's warning about the moon's core might be the most important space discovery of our lifetime. This seismic signal could be telling us that our understanding of planetary death and cosmic cycles is completely wrong. What do you think? Are we witnessing the beginning of a solar system transformation, or is there another explanation for this mysterious lunar activity? Drop your thoughts in the comments below. I genuinely want to hear your theories. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss Simply Science's latest discoveries. Until next time, keep questioning everything around you.